That's what's on the Bakuna amount of person. Hey. Image ball found the move for them.
This Mavis.
Hey, you're going to come. Karonga.
Nothing, I know everything I do.
Not talking.
Instead of you to look and copy, you are there talking. Oh, Jesus.
Why are you subtracting -2 instead of -1?
Why am I?
Why are you subtracting 2 instead of 1?
We have S and Y.
Yes, we have X and Y. Good.
Okay.
Yeah. Okay. And then if I should go that way, if rho is less than 0, we will what? Reject H naught F.
Lantu vitaka pande pelegedia kape revedekasi telegevelekesi tola.
Who is that?
Yamako.
7.
Why? God. Hey. Easy.
Okay, then 4. 4, what do? We make a decision.
In fact, we need his prayers. It's true. We need his prayers.
Make a decision and conclude, right? Okay. So please, what I want you to do is that this work that we looked at, okay, just go back and go through this process that we've done over here and check whether we can actually say that there is what? There is a strong correlation between them. You can use any of the H1s that you want, okay? You can use any of them, any of the H1s. So compute the test statistics, state your degrees of freedom, read it from tables, and then check, okay? All right, so that's part of your assignment, and make a decision whether there is what? A positive correlation, negative correlation between host and this. Any question on this before we call it?
Please, what is the name of that sign?
Which sign?
The one you use under the hypothesis test.
This one, rho, the Greek letter rho. Is that okay?
Okay.
All right. Any question?
Rule.
Okay. So please make sure you go through it. We'll ask you in the exam. That's all you always want to hear. So,
those of you who understand this, please DM me.
Go through it, compute your R, plug it into your test statistic.
The way it was cutting and things. No, I'm lost.
Yes,
I didn't get it. Unless you give us.
He said, do you have the slides?
Which slide?
slides and what you just did.
Not that way.
So some of us, we are lost. Like, we couldn't join the
Say,
first
Please
time.
speak for yourself.
I am lost.
Okay, say, me, I'm lost.
Say,
Bro,
If you are
Me,
lost,
I'm lost.
you will be found. Don't worry.
Say,
We'll send you the
sir,
report.
please. Sir, please, can you go over there and
yeah, my bro, you will be found. Okay,
interpretation
don't
of the
worry.
correlation of
Please, there's some.
Sir, please, can you go over the interpretation of the correlation of coefficient of determination?
The coefficient of determination, the value that you will get. For example, in this case, we got 0.2. So we multiply 0.2 by 100, we get 20%. So what it means is that 20% of the variation in cost of the project or the road, in this case, the road, is explained by the regression on what? On the miles of the road.
Oh, okay.
That's the mileage.
Mileage, yeah.
Sir, please, what of the coefficient of correlation?
This one is level 100. So you get a value between -1. Correlation coefficient is between -1 and what?
Positive
And 1. Okay. So it means that you get to 0. So when it is 0, there's no correlation. If it is -1, there's a what? A perfect negative correlation. If it is +1, there's what? A perfect positive correlation. The positive one means that as one increases, the other increases. So for example, if we get R to be equal to 0.7, positive 0.7, then it means as the mileage of the road increases, the cost of repairing or whatever it is will also increase. If it is negative, what it means is that as the other one increases, we expect the other to decrease. So that's how you explain the correlation.
I'm saying.
Yes.
Please,
Do you mean that if
One at a
there's
time.
another test in the slide?
One at a time, please.
There's a certain text in the slides. How is it different from the one you've given here?
There's what?
There's a certain
FEC.
test
Test.
in the slides you sent to us.
Yes, is it a table one?
I'm talking about where it actually is.
Who is talking about the test? What's your name?
Asking how is different.
Nazir, are you the one asking the
From
question?
what you've written.
Please ask and let's go. I have been at the office since morning.
It was
Please. Yes.
like F sub C
F test.
is equal to SSR divided by 1 or divided Ransford.
What test are you talking about? Is it the table one?
How is it different from what you've given here? I don't know if it was written as F sub C is equal to
F, but they are different. That's what I say. I made comment on it that the slide that I gave you, I mean, that was 2019. That is different from what you are doing now. They are the same. The only thing is that we have pushed some of the concepts into your star 222. So I made mention of it just today. So the table one, don't worry yourself with it. What I gave you in the slide, what I'm teaching you is not in it. Are you okay now? Ransford, are you okay?
Please, I didn't hear what you said.
So, okay, so you take what I have taught you now. The one you are talking about is different. And we are not
Beta
going
is
to
the
ask you that. You will do that in *222.
Please, sir.
Are you okay?
yes, please.
Good. Yeah. I talked about it. Maybe you didn't know it. So in the book, you find a table like this. Then at the end of the day, you have F. That's an F test. A lack of fit test. We don't do it in this one. You do it in *222.
Okay. Thank you.
Any question? Techi, yes.
Yes, sir. Sir, please, the old video, we couldn't access it. They said we
Okay,
should
I think
request
those
for
that
permission.
I'll try and
before.
get it and send it to you. Maybe by tomorrow.
Okay, sir. Thank you.
All right.
Welcome.
Yes, any question again? Yes,
Sir,
yes.
Please, sir, another test statistics. The top one, is it R or N?
It's R.
The top one.
Yes, it's R. Then N.
R minus.
So it's like R. Let me just.
It's N-2.
Yes, R N -2. But this,
okay.
yeah, that's how it is. N -2.
Open your eyes.
Yes, any question again? Any question again? Flaviano, do you have a question? If you have, please, just ask and let's go.
Say about the
Yes.
differentiation with respect to beta naught and
Beta 1.
beta. Yes. When do we have to differentiate? Is it when they're asking of minimizing of something?
Yes. Yeah. So in statistics, you apply those concepts you learn in math. That's why math becomes a prerequisite. So when we have a function and we want to minimize it, we apply those differentiation concepts.
Okay.
At a point, you will also be using integration. Okay, so when we want to find an area, we will then use integration. So in statistics, we also use integration a lot. And especially in Bayesian statistics. Yeah.
Okay, sir. Thank you.
Any question again?
Most people don't do that. Yeah.
Any question?
Sir,
Yes.
Sir, this
sir,
Christmas,
please,
yeah,
with
really
respect
enjoy
to the
crowd.
differentiation,
Yes.
in differentiation, if you want to find the minimum, we find you equate, in your case, you equated it to 0.
Yes.
But normally we find if it's less than 0.
No, you are talking about the second differential. So you can differentiate it again and check the point that you got, whether it is maximum or minimum.
Okay, thank you.
Any question again? Yes.
The test statistics, is it only used in linear regression?
Is it?
The one you gave me that only used in linear regression.
This one? This
Yes.
one?
Yes.
That's only for correlation.
Correlation, okay.
Yeah. Only for correlation.
Sir.
Yes.
Sir, please, in differentiating, do you have to find the equation first with the values before you differentiate respect to the numbers, or you have to find just maybe you had y not equals 2.4 plus 1.2?
No, you are far off. You see, there's a method that we call it least squares principle. To derive it such that you get an expression for beta naught and beta 1, you apply that concept.
Okay.
That's it. And then we get a formula for beta naught and formula for beta 1. So that's it. So when you have a problem, you can use the formula, or if you like, if you want to start from basic principles, you can formulate your equations and do it like that. But usually we don't do it because that's tedious. So if somebody has gone through it to now provide you with an estimator, beta naught and beta 1, you don't go back when you have a data set to now go and solve it from first principle.
Okay.
Yeah, I think we should use like 5 minutes to do that, the differentiation.
I should do it there for you.
Yes, sir.
Yes, please.
My friend, this kind of studies, sit down and work it yourself, okay? We can do it, but it's not helpful. Okay? Work it out. That's what will help you to know how to solve problems, okay?
We want to use our normal differentiation, but it's not working.
It's not working.
Say the problem is we've not done partial differentiation, but in this case, you are supposed to use partial differentiation.
You have not done it, but you know.
I'm just saying that's why they are confused.
Who is your teacher?
But you are not confused.
Hey.
You are not confused, but you think somebody is confused.
Sir, this one you have to take us through because using a normal differentiation that we know does not work for
you
that.
and who? Don't say that in my class.
And I'm part. I'm part.
So someone is also confirming.
So that's your mindset. Somebody is telling you that you are confused and you agree that you are confused.
In this case, we don't know the one which is.
I mean, I started this, so you couldn't, you don't, we started this. You have this expression. You are the university level 200. Okay? It's not everything you expect your lecturer to sit and be different. This differentiation. You said we should sit at 8 o'clock and do it. This one. We started with it. I even did it in class, isn't it?
No, sir. So you just gave us the formula.
But I've done it. I said 2. This is implicit differentiation. And you haven't done implicit differentiation. You have. So you multiply 2 sigma. You said you haven't.
We have done it.
Yes. Then I'm going to do this one. Okay, if I have to, is 2 minus 1, right? Then what is inside the function? But I'm differentiating with respect to beta naught. So it's y. If I differentiate y with respect to beta naught, what do I get?
Negative beta.
You get what?
Zero.
And then I move to the next one. What do I get?
You get 1.
Is it 1? Negative
Negative 1.
The
Negative
next
1.
Get what?
0.
So it's like the whole thing will be on negative, right? Negative. So I can take this one off. Is that okay? You do same for the other one. And set it to 0. Of course, this one is 1. So nothing is there. Please don't say that again. We have not been taught. Okay?
Sir, please, will this come into the exam?
Look at the question you are. Yes,
Well, the exam, you write it.
Are you
If
okay?
it comes, won't you write it?
Are you okay now? It will come.
Yeah, okay.
But I don't understand
You and who personal pronoun.
So this one.
So,
yourself,
what
talk
are you
yourself.
going to use all these things for?
What are you going to use these things for? When you come to school, come to my office. I'll show you some of them. Okay.
Oh. If I'm in my office, what am I going to use all these things
for?
When you grow.
You understand?
Oh.
You mean when you grow?
Hello, sir.
Yes.
The lecturers have to learn this very hard.
Please, this is not anything hard, I beg you.
This
I am reluctant to solve everything in there for you.
Sir, please, I have a question.
Pardon me?
Please, I have a question, but it's related to the degrees of freedom formula sometime they came to give us.
Please, which one for the double sample?
Yes, they came to give us a certain formula.
I said in this class, just use N1 plus N2 minus 2.
Okay.
I said it in class, right? I said it in class. You can use that. We will not penalize you. But it doesn't mean that
everyone ran from class.
Pardon me?
Everyone ran from class on that particular day.
Yes, that day there was no one in class.
There was no one.
You said it better. That were in class.
You were not there, or there's no one.
Just a few people. We came to class, but Sir wasn't in, so we left.
And your magical stuff. Okay, I think we should call it a night. Thanks for your time.
This system is very hard, though. You people, you have to.
I will I'll try and get time for you either in the. I think tomorrow it will be difficult, but please be on the lookout. If I get time, I will let you know, and I'll meet you during the day. Okay. And then maybe example.
Say.
Yes.
I think in class she said something about us doing the ANOVA
learn the cheap things and pass and go away.
Hello, sir.
Yes.
Say. In class, you said something about we doing the ANOVA test. Won't we do it again?
I said we don't have time now. We will do it when you come to school.
So we'll do it when you come back.
Oh, you people!
I beg. This is not 241.
Sorry.
Yes.
During my masters day, I'm going to fight with you.
The big freedom. It was changed the other time. We said that assuming they say that the virus that's where we use the N1 plus N2 minus 2.
Have you covered your mouth?
You go for cancer.
Oh, no. Hey, allow him to ask his questions.
Can't hear him. It's like he has covered his mouth.
So you said that the virus are what? That's
in the class. Oh.
Okay. So that also for virus and not pepper. I don't know you use N1 plus the 2. That is unequal.
Speak English.
Yeah, please, can you hear him?
I only need,
He's using Ito.
Okay, have a nice evening. Okay. So please be on the lookout. Maybe tomorrow. Have a nice evening. Take care of yourself.
You're talking like that.
We'll see you next week, okay?
Can you hear me now?
Bye-bye.
We have to take your time with us.
Speak according
You are using Ito, and you are using.
Davis, can you hear me now?
Yes.
Sir, as I was saying, the degree of freedom. The other time you stated that if the variants are unequal, we use the N1 plus N2 minus 2. But if when they are equal, we use the one that you said S1 squared over N1 plus whatever squared divided by that one. But right now you said that we should just forget about what it was changed the other time in class and use the old one.
I said is the degrees of freedom.
Clifford, listen.
That the degrees of freedom do not use the formula one. If you can use it, fair enough. But we will not penalize you if you use the N1 plus N2 minus 2.
Okay, sir.
Yeah. That, at least in this class.
So even in
Okay, sir.
exams we can do so.
In what?
I mean,
I said only in this class. Okay, I think it's enough now. Thank you.
Okay, sir. Have a good night.
Okay, bye-bye.
Well,
Happy New Year.